Algebra of vectors. In this lecture, we shall discuss the basic algebraic operation with vectors in three-dimensional space. Since forces, velocities, and various other quantities are vectors, therefore the algebra of vector is of great importance in mathematics, physics, and engineering. Scalar and vectors. Scalar, a quantity which has only magnitude but no direction, is called a scalar. For example, mass, density, volume, length, time, temperature, speed, and any real number. Say pi, e, under root 2, under root 3, 3, 5, 7, etc. and so on. The value of a scalar is a single real number with an appropriate unit of measurement such as centimeter, cubic feet, degree, second, and other units. Operation with scalar follows the same rule as in elementary algebra. Vector. A quantity which has both magnitude and direction is called a vector. For example, displacement, velocity, acceleration, force, and momentum, etc. A vector has two different natures, one geometric and other algebraic or analytic. To study the applications of vector, we need an understanding of both aspects. Geometrical representation of a vector. Geometrically, a vector is represented by a directed line OP, whose direction is that of vector and whose length represents the magnitude of the vector. The tail end O of the arrow is called origin or initial point of vector, and the head P is called the terminal point. Analytically, a vector is represented by a letter with an arrow over it as a vector A. The magnitude of a vector A is denoted by magnitude of A or simply A and is equal to the length of OP as shown in the figure. The magnitude is also called the length or norm of the vector. When the initial point of the vector is fixed, it is called fixed or localized vector. If the initial point is not fixed, it is called a free or non-localized vector. Equal vectors. Two vectors A and B are said to be equal, written as A is equal to vector B if they have the same magnitude and the same direction regardless of the position of their initial points as we draw. Thus, a vector may be shifted from one location to another, provided neither the magnitude nor the direction is changed. Negative of a vector. A vector having the same magnitude as that of A but with direction opposite to that of A is defined as the negative of vector A and is denoted by negative A over arrow as shown there. Unit vector. A vector with unit magnitude is called the unit vector or direction vector. The unit vector is the direction of a non-zero vector A denoted by A hat. is defined as vector divided by magnitude of vector. Thus, this vector is can be written as vector is equal to magnitude into unit vector, which shows that any vector A can be represented by a product of magnitude of vector A and the unit vector A hat in the direction of vector A. Note that to emphasize the fact that a particular vector is a unit vector, we put a hat or a card over it as A hat, B hat, and so on, etc. Null or zero vector. A vector which has zero magnitude and no specific direction is called the zero or null vector and is denoted by vector 0. Geometrically, a null vector is represented by a point, such as a point. It is only vector we cannot represent as an arrow. A vector which is not null is called a proper vector.